Ready? Okay. Let's go over again what acceleration is. Okay? Acceleration is the rate of change of velocity. If you're looking at an acceleration time graph, it's also the slope of the velocity time graph. Now in this class we only deal with constant acceleration. So when we look at a graph of acceleration versus time, in this particular class, we're only got one of three things we're going to see. You're either going to see a horizontal line along the axis, meaning no acceleration, a horizontal line above, or a horizontal line below. Now that we know that acceleration is just the slope of a velocity time graph, we can now analyze what the motion should be looking like. The tricky thing about acceleration is we don't have a lot of information. We don't know what velocity we started with, and we don't know where we started. So as a consequence, each one of these can mean a number of different things. If this is the slope of the velocity time graph, it's saying we've got a constant slope or zero acceleration. How would that appear on a velocity time graph? There's three different options, believe it or not. Even though it's zero acceleration could mean the object is in fact not moving. That would be one option because the slope of this velocity time graph is zero. But there are other situations where the slope is also zero. For example, this is one case, this is another case. Yes?
Is one more accurate than the other?
No. There's just not enough information here to be able to tell. So it could be any one of those three. What you do know though is that if the acceleration is zero, that means the slope of the velocity time graph is zero, which means any horizontal line on the velocity time graph could be what's going on. So in this case, that says that the object is moving in the positive region, so it's moving away at a constant velocity. This one means it's not moving. Acceleration is still zero. And this one means that it's moving towards your reference point with a constant velocity. This one covers this situation here. What about the other two situations? Well, they're similarly tricky. All right, so let's come over here and look at this purple line, which is above the axis, and see what that might do with a velocity time graph. Okay, so we have, according to this, a positive and constant acceleration. That means that the slope of the velocity time graph must be positive. If I want to put a velocity time graph that's positive on this, as a positive slope, this would be one option that has a positive slope. But interestingly, So does this one. This one is saying that the object is moving away at an ever-increasing speed. This one is saying the object is moving towards at an ever-decreasing speed. And then finally, we have anything in between. So in this case, we could have that. The slope is constant. It's only one value. So that means that the velocity is changing. And remember, we will only ever deal with a constant acceleration, that is, a constant slope for the velocity time graph. Right? What does this one say? This one says the object is moving towards our reference point at an ever decreasing velocity. It reaches zero, turns around and goes away, first slowly and then at an ever increasing velocity. And you know what the position time graph looks like for that. It's a parabola. Okay, so now let's have a look at this third option here. Right? We've got a constant negative acceleration. How does that translate into a velocity time graph? All we need to remember is the following. Acceleration is the slope of the velocity time graph. Therefore, if we have a negative constant acceleration, it means that we have a slope which is negative, but that slope remains the same. So let's put in some values for that on this velocity time graph. That's one possibility. That means that the object is moving towards our reference point and it's speeding up, right? The negative velocity, or the going away, is getting larger. We have another possibility though. We also have that as a possibility. What does this one mean? We have a negative constant slope. Right, it's going away and decreasing. Right? First, we know that it's in the away region or positive direction region of the velocity time graph. So we know it's going away, but the value of the velocity is becoming smaller as time goes on. So it's slowing down. If we look again, we can see that, again, we could have any line parallel to that inside here. Let's take the middle one. Now, what is this one saying? This one is saying we start off moving our reference point, all the time slowing down. We reach zero velocity, i.e. we stop momentarily, very momentarily, and then we turn around and start going back the other direction, increasing our speed all the time. Right? So we were going away, now we're coming towards. So the key thing to remember is that acceleration is the name we give to the rate of change of velocity. When you see the word acceleration, you could actually cross it out and just say change in velocity with time. Or you could just say, oh, that's the slope of the VT graph.